All right. Hi. So we definitely haven't had enough DAT talks this conference, so thought we'd talk about another cool thing, which is getting DAT to work on the web. So before I get into that, let me just introduce myself. I'm a Ranger Mauve everywhere that it matters. You may have not seen any of my modules because they're not very good, but I do like to lurk in a lot of cool places. So my nickname is like Mauve or Ranger. I have a human name. I don't care about it. I'm currently working for the DAT Foundation, and I also have a company, but DAT is my passion. So let's quickly just recap on what DAT is for like the third time. So basically, it's a file system. It's a file system, and it's a really cool one too. You can create it anywhere, you can like shove stuff in it and then have that stuff magically appear somewhere else. It's really cool. All that is actually encompassed in a single module, hyperdrive. And that's kind of what I like about DAT. It's actually not just one thing. It's a bunch of like cool little pieces that you can glue together. And there's one kind of like main way to do it that's in a CLI, but it's all like very easy to just like hack around with. So in addition to the file system, we actually have the storage in a totally other like ecosystem called random access storage. And so that's how the hyperdrive actually interfaces with something to actually like store the files. And what's cool is there's different implementations of this interface. There's the file system. There's just memory for when you just want to load something in memory and forget about it. I think there's like Redis, I think like Amazon, like just a bunch of crazy stuff. But it's cool because it's very pluggable and very modular. And then finally, there's the actual peer discovery. So like many peer-to-peer protocols, we have a bunch of peers that we connect to. It's pretty great. And all of that is encapsulated inside the Discovery Swarm module. It's what DAT uses to advertise your IP address for a hyperdrive you have. It's what it uses to find those peers, and it actually coordinates connecting and keeping connections open, which is pretty fun. So, okay, that's cool, but none of that stuff really works on the web, which kind of sucks. We have all of this cool stuff in Node.js land, but it's only really in Node.js, which is like half of JavaScript. Hopefully it'll be less than half going forward. Oh, controversial. However, a lot of people that use Node.js also use the web. Like, go figure, JavaScript developers. And there's a really cool tool that gets us pretty close to getting DAT just like compiling at least. And so that's in the form of Browserify. So what's cool is that most of the modules in the DAT ecosystem that don't touch like the file system or the network directly, you can just shove into this like magical build tool that's just so much nicer than Webpack configurations and Babel, and just like, I don't get seizures when I use Browserify. It's pretty useful. But this actually gets us really far. And before I even got really like super involved in the DAT project, there was actually already a DAT on the web. Wow. And that was using WebRTC. So WebRTC, for those that don't know, it's like peer-to-peer connections on the web, or sorry, real-time connections on the web. And they kind of got it working. You could create a DAT, you could find other browsers, connect to them, and it's great. There we go, talk over. But sadly, it wasn't enough for what we could do. WebRTC connections are kind of slow, like you can't have a lot of them at a time, and the ones you do have are probably not too bad, but it's kind of limiting. As well, there wasn't really a good story for persisting these archives in the browser. I think by default it was just using in-memory storage, and the main sort of like random access thing for the browser was IndexedDB, and I think someone already complained about how bad that was. And then lastly, since it was all WebRTC, you could only connect to things through WebRTC. That meant that all of the DATs people created in Beaker, in the CLI, all the stuff in like Cabal and any other thing in the ecosystem was completely separate because it just didn't have that same connectivity level, which kind of sucks. However, there is more than just WebRTC on the web, specifically WebSockets. Okay, this was way bigger on my screen before, but that says WSS for WebSocket protocol. So what we can do is instead of using WebRTC to connect to other browsers, we can cheat and use a server. So that's what Dat Gateway did. Essentially, you have this server running somewhere. You open a WebSocket from your happy clients to this server somewhere. The server then connects to the swarm of cool guys, and then it will replicate a hyperdrive with the cool guys, and then replicate that same hyperdrive to your browser over the WebSocket, which was cool. Now, it was pretty fast to load a DAT from the network. You could advertise a DAT you created locally to the rest of the network and discover these DATs. So you can create one in the CLI and run it and find it in the browser, or vice versa. And what's cool is this was actually compatible with WebRTC. So WebRTC was kind of like the first choice, because if there is a browser peer you can connect to directly, that's probably cheaper for us than the gateway. But the gateway was there to get new content into the browser network and out of the browser network. Sadly, the gateway, it wasn't enough still. It was better than just WebRTC, but there were still some like things that kind of bugged me about it. Specifically, the gateway, since you sent it your DAT key and had it replicate a hyperdrive, it could see everything that you were loading, which, you know, generally isn't a problem because you can generally trust gateways run by people in a community that you trust, but it's better to just not have to worry about that too much. And also, I don't think that, well, myself as someone running a gateway, I don't really want all of your personal information in clear text on my server. That's like way too much liability. And also, it wasn't very flexible. It only worked with hyperdrives, and it didn't let you actually connect to other peers. So that meant that you could do this like simple use case of replicating a hyperdrive, but cool things like Cabal weren't really possible with it. And I really, you know, wanted to support that. So I was looking into this and I was thinking, like, maybe we could have both. Like, why not have a gateway and have privacy and have flexibility? It'd be awesome. So hopefully this is even slightly visible. So I'll go over it though. So essentially what we wanted to do was we wanted the gateway to act as a sort of proxy. So I open a connection to this gateway. I tell it, hey, find me peers for this DAT key. It would then go to the swarm trying to find peers. Once it connected to a peer, it would then proxy that connection all over one socket. So this is great. Now we could have like real innovation inside the web space. Using DAT. You can get whatever DAT protocol or whatever DAT-based thing you want, shove it into the browser, like sprinkle this like gateway magic on it, and then it'll just work. Performance was still a little bit of an issue though in the storage space. So as I mentioned before, IndexedDB, really not fun, but you really do want to store stuff sometimes because, you know, I don't like losing my private keys very much. So what's cool is there is a bunch of innovation in this space already. There is random access DB, random access Chrome file, which uses like this totally non-standard file system access thing from Chrome, and random access IDB mutable file, which is like another totally non-standard thing that only works in Firefox. Yeah. So in practice, this meant that either you used this slow IDB thing and it worked everywhere, or you only target Chrome apps, or you only target Firefox apps. And it was just like a pain in the ass to innovate. So what we did was we took all of those things together and just put it behind one interface called Random Access Web. So now if you want to like store stuff in the browser using like hypercores or whatever else that uses random access storage, you can just npm install Random Access Web, plug it into your hypercore, and it'll actually choose whatever the best storage mechanism is. And this actually changed things a lot. Combined with the new network stuff, we can right now really quickly load up DATs, do random socket stuff, have a bunch of hypercores, have it all work offline, and all that great stuff. And this is all integrated inside, oh my God, it's so tiny. I'm so sorry. It's all inside dat.js. And what I find more exciting than just dat.js is dat archive web. So Beaker, as Paul presented before, it has a lot of cool things for just building apps using these peer-to-peer technologies with JavaScript and some HTML and all this cool stuff. And it's just like really high level and easy to use. So the problem is once you take these apps and you put them in a regular web browser like Chrome or Firefox or Edge, it just doesn't work, and you don't really have any way forward. So what's cool is now you can squint really hard and include a script tag for this dat archive web thing, and then you can just use the dat archive API in your app. So in Beaker, it'll actually use the native dat archive API, all the good peer-to-peer stuff, but it'll gracefully downgrade for people that are, not with the times yet, and still work. You can still do all of your cool dat stuff. So nice. What I like most about this, though, isn't just that we have the dat archive API in the browser. What's cool is that similar to how the rest of the dat ecosystem is just so kind of modular and piecewise, we now have all of these cool modules to play with. So in addition to all of those different data structures we have in the dat ecosystem, now we have just a general purpose peer discovery thing that can be reused everywhere with very little buy-in. Like the API surface is literally like join a key and handle a connection. And this could be used not just for dat. I'm going to be experimenting with this for peer-to-peer multiplayer VR. But you can use it for whatever other application you can think of. And the goal is really to not just make things that like work for just this specific use case, but really to make things that are modular that let people experiment. So if any of you are kind of like curious about getting peer-to-peer-ish stuff working in the web, I suggest you just dig into this source code, say maybe check out the Cabal source code, and maybe submit a PR that makes it work on the web. Thank you.